Thank you for joining the more boring of the two presentations that are going to happen in the same time. We're going to be talking about the Redis MCP server, which is something quite new that we're working on together with part of the team here. Vital part of the team that's actually building it still hasn't arrived, but he would be here to answer more questions if you have, because I have a fairly good understanding, but the expert is he. He's the expert for that. So, first of all, my name is Tihomir. I've been working for quite some time at VMware, where I was doing a lot of different things, mostly focused on UI, but also backend and full stack and whatever was needed. Then I switched to Redis 2 years ago, and as part of my job there in the ecosystems, clients and ecosystems team, I'm working on the contributing different features to the ecosystem. Before that, I started by maintaining the open source Lattice driver, which is a Java asynchronous driver for connecting to Redis. And very lately, we've been contributing to LangChain and to Nathan as part of the AI effort that we all love and like to hear more about. A huge disclaimer, and I'm obliged to say that, most of the things are in incubation right now. The MCP server itself hasn't yet reached the version 1 state that we would like to have soon. So things may be changing quite a lot in the coming days and months. This is the agenda that we would like to cover. I assume that most of you have some prior knowledge about how AI basically works, generally works. We're not going to have a deep dive there. But I'm still going to have a few slides on what is MCP and what are agentic flows, just to make sure that everybody in the room is having some basic knowledge that we can step on, and then talk about the details in the Redis MCP server. Then I'm going to show you two major ways of using the MCP server. One is for improving your developer experience, and the other is as part of agentic flows that you may want to write or your software might participate in. And I'm going to mention briefly how other products in Redis are also exposing MCP interfaces as part of what they're doing. You may notice that here and there stuff would be duplicating itself because obviously we're still figuring out stuff. Like the whole MCP protocol is quite new, and product is still attempting to find the right place for all the features, and there are some overlaps here and there. But we'll be mostly focused on what we can do right now. So what's MCP? MCP is a protocol that you could use to have a standard way to talk to your external tools from the side of the LLM. So if you're using Claude, GPT, Llama, these are just examples. It could be any type of large language model. Agents that are participating there used to talk to other tools like, again, just for illustration purposes, here it's GitHub and Drive and Slack, but you could just put anything there. Before that, before the invention of the MCP, they would all have to duplicate the unique API that each of these services exposes so that they do stuff with it. Like if you ask your ChatGPT agent, because it has to be an agent in order to do stuff, if you ask it, please check my mail, it would have to use a specific protocol depending on what your mail service is. With the invention of MCP, this became a bit more standardized. You have a protocol, it exposes certain tools in a certain way, and allows you to have this abstraction layer between the two parts and make it much more easier to talk to these external tools and do agentic stuff. We'll talk about agentic stuff later, if you don't know what it is or like to refresh your mind. It uses JSON RPC for communication. It's bidirectional, so you could also send from the MCP server, you can send push messages to the agent. Like, for instance, you may want to refresh the list of tools that you're providing there, and you could do that without it having to query you for this. And that's like a very brief overview of what MCP is generally. And I can also tell you a few stuff about agentic flows. It's a very complicated thing that I'm going to try to explain very briefly, so I'm bound to say stupid stuff. Sorry about this. There's a very nice paper here mentioned in the bottom that explains all the pitfalls of creating agentic flows right now in the industry. It's a bit dated, by the way. It's to 2023, I think. But it still outlines a few issues and obstacles to make it better. Basically, what an agentic flow is, you have some software, which we call agent, and you would want it to do something. So you put a prompt there and say, what can I do in order to get this software to talk to this service and send data to this service? What the agent does is it queries the LLM and asks it to build up a list of things that it needs to do in order to achieve the goal. So you have an overall higher goal that you're aiming at, and you break it down into different steps. You, like tasks, you put it in a list of tasks, and then again you do the same thing. You start the flow from the beginning, and you ask, what do I do to do this specific step? Until you get to the point where you actually could use tools. So the tools would be the actions that you take in order to get to the goal. And you could utilize multiple tools to do your specific goal. It could be just one tool, depending on what the LLM says. And it could be something really bad. It could be something really bad. Because, you know, AI is not perfect, far from perfect. So you have the option to allow it to do it by yourself, or you can approve each of the steps needed for achieving this task. Most of you have used it, but I'm explaining with more detail just to make sure we're on the same page. In this whole picture, MCP is somewhere here in the tool, the act part and observation part, because observation is the result from the tool. Like if the task that needed to be done resulted in an error, the LLM needs to correct itself, the agent needs to correct itself, and obviously it needs to take this error, send it to the LLM, say, okay, I tried this, but it failed, and then do corrective action. Just put another task in the list before continuing forward. Very, very simple explanation for something really complex, so I'm bound to have skipped stuff. I'm only explaining from the perspective of the MCP so that you know where it stands in this agentic flow. And this is a very, very crude, just to give you some idea, picture of these things that go around the JSON RPC when the MCP server and the MCP client, which is the agent, talk to each other. So usually they start with a tool discovery. So when the agent first talks to the MCP server, it says something like, okay, give me a list of the tools that you're providing to me. And I think this is the reply that I've showed there. Sorry, it's not very obvious which is a request and which is a reply, so I'm going to give you context. This is the reply to the discovery, because the request itself is just a couple of lines, give me the tools. And this is the reply, so the server says, I have a tool that's called calculate arithmetic. The title is the friendly name that could be shown to the user later. What it does is it performs mathematical calculations. What it needs to work is some sort of a mathematical expression in the form of a string, and it's a required parameter. You could have many parameters. This is basically you're defining your API contract from the perspective of the LLM. The LLM needs to know, the agent needs to know how to talk to you in order to fulfill the tools usage pattern. Then when the user actually inputs a prompt, the agent would ask how to do that, and if one of the steps is you need to perform a mathematical calculation, it would match this. You know how this works with a vector similarity, and seeing the description, it would know that this two would work. Now, a very reasonable question is, what would happen if you have many tools and some of them define the same contract? And the answer is, it's unpredictable, so every time it would be a different thing. But this is how it is right now, as far as I know, of course. You're all folks here are very welcome to correct me, because this is very novel and some of the things are maybe changing. This is what I saw last time. I was wondering what will happen if you define a very broad contract and say, in order to do whatever, just go to this tool, and it kind of worked. I mean, it went there most of the time. Sometimes it went to other tools too, depending on, vector similarity. So the request is, yeah, I know that you're doing this, so please do that. In this case, it requires us to get the current weather, and it provides the arguments which are required, location, and probably the units are not required, but they still would want to have, for some weird reason, Imperial. I would not do that, but I'm a European. And then the response is, obviously, again, to this same request. This is a text response, and this is the weather in San Francisco. And this is the whole flow that you have here. It's very simple, but it could be used to do some very complex stuff, which I will demonstrate later, hopefully. And again, this is LLM. So we are going to see a different version of what I tried yesterday when I was trying stuff up. So some stuff might not work, but generally, we want to get the picture. So how does Redis come here? Well, one of the things that our team decided we could contribute in this flow with is to provide this MCP server, which stands as a LLM contract in front of your Redis database. One of the biggest advantages that you have right now is that you are having a very good contract, in confidentiality contract, or whatever you call it, in terms of where your database is, what the credentials are, how you connect to it. If you would not use the MCP server, because you could, if you'd like to, you could use some other, like command line to Redis CLI, for instance, you would still have to provide the LLM and send this information to the LLM about where it is, how to connect to it, and you may not have the option for that. So one of the biggest, I would say, reasons to use it in the first place is that you keep your connection information, locations, and stuff like this inside of the MCP server, and don't have to expose it to the LLM. To the LLM, this is just a tool that says I can do Redis stuff, which is nice. But there's also different other things that you would benefit from, like a more clear contract, some more functionality, because it not only stands for the database, but it stands for the knowledge base. I'll talk about this later. So you could basically use it as a RAG. And I'll talk about this later too, what RAG is, if you don't know. But you could actually say stuff like, how do I do a leaderboard? How do I implement a leaderboard? And it would provide you, the MCP server would instruct the agent that it knows how to give out such information using Redis, and it would provide you this information. And yeah, and of course, the obvious biggest reason that you could use it is you need, in your use case, to have a semantic way to query the database, because it's a different way than a normal API. APIs are strict. You use a certain framework, a certain protocol, and this also is strict and uses protocol, but it's the semantic approach. So it's a native to the AI flows way to connect to the database, because you might not have other ways to access it than this way. No, we get to the demo already. So in this demo, I'm going to show you specifically how the developer experience, data access improvements work for the MCP server. Bear with me, it may take some time. But, so sorry, I didn't finish my thought. What I will use is IntelliJ as an IDE. You could use any IDE for this purpose. I'm using also Augment for the agent inside of the IDE. Again, you can use any agent that you would like to use. And of course, we need the Redis MCP server, which is installed in the agent. This is the flow. You need to install MCP server in order to be able to access it whenever you need to do stuff with it. Check, nice. So what we're going to do is we're going to ask a couple of questions to this agent, and the agent will decide, hopefully, to use our MCP server and show us the actual results. It's a very demo project that you try to ignore. It's really not very interesting. It's just used for demonstration purposes. So this is how we open Augment IntelliJ. You have here a tool. And we start a new conversation. And this new conversation ideally should not have any context for us to be sure that we are doing the same thing that we want to do. So we have the project here. Let me talk about the project. So the only thing that I want to have in this project is this model class. It would serve as a very good context to our demonstration. So it doesn't, I mean, details here are not important. But basically, I've asked the AI to render a model for me in a Spring project that represents a Reddit article. And I would use this model to ask the agent to do stuff. For instance, generate a sample data based, oh, sorry, I can use it just here. So we want to do sample data. We want the agent to build up sample data for us and put it in the database. This prompt may not be enough, but hopefully adding the context here. Sorry. Yeah, and one of the things that I've noticed is Augment does not play well with me when I'm doing demos. And here I would put the model name, the model class, just to make sure that the agent knows what model I'm talking about. Generate simple data based on my model in Redis, just to make sure it doesn't generate it somewhere else. And now what would happen, hopefully, is the agent would, not have internet, probably. Yes. I'm sorry. Congress Center? Should I be worried about this? No. It should be okay. And we try again, this time with internet, because AI needs internet, obviously. Hopefully the agent will now see what it needs to done in a list of tasks. It would read the model to see what the model is. It would put it in its memory to know what it needs to do. And then it would query, you see here Redis MCP mentioned. This is the MCP that I previously installed. I'm going to show it to you. That was something I could have done. What it does now is it basically says, I want to set a JSON document. I want to store a JSON document in the Redis instance, which is pre-configured based on this model with some sample data. And because it's very thorough, it would probably want to know if the server is up and check if we had this done. It would eventually, and I didn't say how much data, so it's improvising right now. It may decide to do a lot of data. Last time it was 10 entries and it was enough. But, oh, Redis is not running. Okay. Let's see why that is. It started? Very smart. Good boy. I hope it's the right server, though. Okay. So this is a very good explanation. now it gives me the option to talk more. First of all, it saw that Redis is not running, and it started Redis, but it started a Redis instance that does not have JSON, so it asked the LLM what it should do, and the LLM said, the model said, well, you should probably use then hash sets instead of JSON, and it's now doing a hash set, which is good improvisation, and it's not very important to us. What's important to us is that it's using the MCP server, and it's basically contacting this Redis instance. We'll see here, yep. So this is Redis, I've opened Redis Insight. This is the tool that you could use to check out what's in your database locally. And we can see now that these articles are added. I see 8 of them. So we decided to put 8 today. Okay, it's a good number. And you can see that it puts inside of it some interesting information just to fill in some data. So assuming that you had a task to have some sample data to test your functionality, this is a very good way to do it. You just go to your agent and you say, use this model, generate some data, and it tries to hallucinate the thing that is most beautiful for you. What else we can do? We can do stuff like, for instance, verify that there's at least one Reddit article in my store. Again, it would use the MCP server once it builds up a list of tasks to verify that. Well, to be fair, it already did that, so we're just repeating the same step, but I wanted to illustrate how it does it. It goes to the tool, it tries to fetch all the data. Probably not the best way to do it, but for our purposes, it would work. And then it says, yes, we have data, always fine, eventually. Yes, there are already articles in your Redis store, 8 articles, key pattern, and stuff like this. And yeah, I'm not going to show the others, but you could do some stuff like how many articles are there. I just imagined what would be interesting to a developer in that case, and you could have different questions about your store that would affect your logic or testing. Like if you're doing integration tests, you would like to verify that in a live database, all the fields are always filled and data is not missing from some of the fields. Or you would want to do some analysis. Whatever you want, this would help you to basically browse your data inside of your Redis instance. Now, another thing you could do besides the data access, and this is the demo, is you could also use the server as a sort of a knowledge base improvement. You know that all the models are built in a certain date at a certain point of time, and they need time to be updated again, which time they're not updated daily or hourly. And for the purposes of always having the latest information and always having the most relevant information, and of course, they're not built on data that's not publicly accessible. So if you want to ask questions to the LLM that would require data that's not public to the LLM, you need to provide this data to the LLM so that it gives it to you. And this is where RAG, retrieval augmented generation comes. It allows you to create a flow where you would still use the large language model as you would normally do, but you would kind of inject in your prompt more information coming from a specific source. In this case, what we do, our MCP server, and I'm sorry about the name here, Copilot. This is not Copilot, not the actual Copilot. This is how we code, for now, the server and chat that allows you to query the knowledge base of Redis. So what the MCP server does is, when it registers a tool to the agent and it says, I'm knowledgeable about stuff about Redis, and if there's a question, you should know that you should ask me. And whenever the user prompts something like, how do I do a leaderboard with Redis, it would go through the Redis MCP server, it would ask Copilot, Copilot would query a smaller language model that we have with the vector store with our articles. It would find the corresponding article that you would want to have. It would give it back to the MCP server. It would give it to the actual app, and it would add it in the prompt to the LLM. So it would say, aha, having this article in mind, how do I do a leaderboard? And it would form it in a very nice way. It's a very nice thing. I've used it several times, and it mostly worked. So we'll try to test it again. One of the things we want to do is, like, for instance, ask it how to implement a rate limiter. I know that there's an article we have that explains how to do a rate limiter, or a leaderboard, or approximate geolocation, and right behind caching. So all of these techniques are already in the knowledge base. So if you have the MCP server, and the MCP server this is a knowledge bucket, this is why it's there. And the MCP server is installed on your environment, it would augment the data returned from the LLM with what we provide in the database that Redis has. So again, opening a new conversation, removing these just in case, crossing fingers as usual, not working because I can't select it, augment. This is not a very good advertisement for augment, I have to agree. How do we implement a rate limiter? Now, I assume it would, because it uses local memory, it knows that I've been asking questions about Redis. So what it did is it assumed that I want to implement a rate limiter with Redis. So it's now outputting how you would do it. I didn't specify a language or anything else. So the longer the prompt, obviously, the better the suggestion you receive. I'm just asking a very general question, so I'm receiving a very general answer with, I think, Python. But if we scroll up, you'll see that this is a very good detailed explanation on how to build a rate limiter with Redis and with Python in this example, I think. Yeah. So it works again in a similar way with all of the other questions that we have, like geolocation. How do we do a geolocation? You would ask it, right? Again, like this. And you will notice that it always contacts the actual MCP server. So this is the request to the MCP server. You can actually see, okay. We have some error that I didn't see before, but it would return again the data. And this is the two developer experience examples that we, sorry, this is not what I wanted to start, that we wanted to talk about. Now, this is the part of the work of the MCP server that's mainly focused on developer experience. Another thing that you could do, as I mentioned in the beginning, this is the second larger part. Well, not larger, but the second large part. There are two large parts right now. The second large part is you could do put it inside of some sort of an agentic flow that is larger than just a single call to the MCP server. In this case, it's a very, very crude example and probably doesn't make a lot of sense, but in this case, what we're talking about here is the agent is asked how to do a certain task based on several data sources. For instance, we want to rent a cheap apartment in Madrid or Toledo, and we want to know which of the two cities has a better weather. For some reason, both of them will be okay for us, and we want to choose based on the weather. And we want to store the data in Redis so that later on we can use it to make a reservation, because for some reason we require that. And in this case, there's several MCP servers involved, obviously. There's several different services involved. And in this agentic flow, you would have communication going all the way. And our example for that, did I miss something? I don't think I did. Oh, yeah, that's the flow I missed. So in this flow, just to illustrate it, I think I explained it already, and it's kind of obvious, but what would happen is you would have the agent, the mobile phone is where the agent is, assuming. It would start from, like, in this case, we keep a session in Redis, so it would ask the agent would ask for this session for some reason. It would get the session. This session could have like things like credentials for one of the services. You could put them there and not have to put them somewhere else. And it would then go to the weather MCP server, because obviously we want to check that. The order may be different, by the way, depending on how the tasks are returned by the LLM. But in this case, this is what happens. You go to the weather MCP server, you ask for weather forecasting matters into Lido, you get the information, then you find rooms in, well, in this case, obviously, you have to first go to the first one because you don't want to query both cities for options, but it may happen that it does it the other way around. Then it would search for rooms in the city that has the better weather, and then it would store the information in Redis as the tasks and the different services involved. For the purpose of our demonstration, we'll be using, we'll be using the Cloud desktop. Now, I forgot to show you, just one step back, I'm sorry about this. I forgot to show you what it looks like to set up MCP server inside of IntelliJ with Augment. So you have here the settings that you set up for Augment, and you have different types of services that are, because MCP servers, that's something I forgot to mention, I'm sorry about that, but MCP servers could be local or remote, either utilizing the STDU standard I/O or using the streaming HTTP. So you have a list of services on top which are publicly available, and you could easily connect to them using some credentials. You could also add new ones or local ones. In our case, the MCP server right now is a local server, and to add it, you just input here something like, the example is self-explanatory, but you provide the way to get the server, how to start it, and how to call it. In our case, we have the UVX Python manager to download it from GitHub, and we have, well, that's it. The name is Redis MCP. In a similar way, if you want to use it in another application like the Cloud desktop, which is an agent, obviously, you have to specify the settings, and you have, in this case, all these things you're seeing here are changing very rapidly. Right now, in the current implementation of, I probably don't see anything. So let me see if I can do something about this. No. Okay, I'm going to talk over it, and you're going to act like you're seeing it. But this is JSON. And these are several MCP servers which are described by their type of communication, standard I/O here, the command that you have to execute, and the parameters that you have to provide to it to start it. And in our case, we have 4 of them. One is the Redis MCP server. We also have the Reddit server for some reason, which we don't need right now. Don't bother using this API key. I knew it was going to become public today, and it's going to be lasting only for a couple of hours. So it's just a temporary account that I have with AccuWeather, because this is where I get our data from for the example that we do. And we have on the bottom the Airbnb MCP server, which we're going to ask about prices and availability for our question. So you see the result here from the last question that I asked. It does the same thing. I'm going to see if today what it would return for the same thing. So we ask, find a room in Madrid or Toledo for tomorrow where weather is good, and store it in my local Redis instance. It would go to the first server, and it fails because the API key, I think, is no longer working. So it's reverting back to asking Google or some other search engine. It says, cannot access local variable location. Okay, so that worked yesterday, and we got from AccuWeather the weather in the MCP server. But the good thing is Airbnb works today. So we managed to ask the MCP server of Airbnb to give us information about Toledo, because the weather there is write, and we decided this is a good idea. And then we will save it in Redis. And I think it also failed, or no? It is. So yeah, that's an example. It doesn't make a lot of sense, to be honest. It's just demonstrating how this MCP server could participate in agent flows. You could, of course, use your Redis CLI for that purpose, but it has several caveats here. First of all, it needs to be installed, obviously, where the agent is running, which is not always possible. Another thing is you have to provide it credentials, which is always also not very good in all cases. And last but not least, you basically have to cater this whole installation. And yeah, the next thing I wanted to mention after this demo is, unfortunately, I have to apologize to everybody here. I didn't get to actual demo here of Nathan with MCP. Nathan is a workflow orchestration server that you could run either locally or in the cloud. And you could define there flows that start from some point like receiving a message, or they're called triggers. So you can have different triggers for this. The two QRs, I promise they're mostly not viruses. The first one is the actual article in the Nathan documentation, how to use this MCP flow. The second one is a YouTube video of explaining that. By the way, if you're going to do something, if you're going to visit one of the two links, visit this one, because it will help you better understand how this works. And the guide there explains how this flow here, you receive a chat message, and you use the agent to do stuff like augmenting the reply with data from a service, or exposing a type of a search with MCP. What I wanted to do with this flow, if I had the time, and I'm sorry about this, was I wanted to do the MCP server, the Redis MCP server, exchange it as a node here, and make sure that whenever a message is sent to the chatbot, it would search in the database that's behind the MCP server, and it would augment with data from the search. So you have RAG again with data which is augmented not necessarily with a vector search, but it could be any type of search. It could be a normal structured data search. Like you want to, for instance, you have in your Redis geolocations, and the person says, I'd like to visit Toledo, but I don't like the city itself. I'd like something smaller around it, like in 50 kilometers range. And your MCP server here, if it has that information, it could say, oh, Toledo, we have another booking that we can make for you, which is in some small town, 50 kilometers close to it. And it would augment the chat message and the reply from the Nathan server. And this is the last thing that I wanted to show you. Again, I don't have a demo, but I'm going to talk a bit about it. Several times I mentioned agent and memory. A very interesting topic and very important for everybody that is involved in agents, in developing agents or working with agents, is how short-term and long-term memory is stored for an AI agent. Obviously, you could do partially some of the stuff with the MCP server, the Redis MCP server, but you have to do a lot of stuff yourself. What we have in Redis additionally is the Redis agent memory server. It's a dual-purpose server. It has both a REST and an MCP protocol interface, so you can query it with both interfaces. It doesn't matter. And it provides you with the ability to store data for the duration of the session, or the duration of like the whole persistent approach, where you know that this person would like to always search for vegan restaurants, and you store it in a long-term memory. Every time he is asking about, I want to go to a good restaurant in Sofia, it would fetch this preference from the long-term memory, and it would return it back to the LLM so that it caters the result based on this information. The short-term memory obviously is stuff that are conversational, they're part of this conversation, helps the AI look more human because it doesn't give out answers that make no sense, having in mind the conversation that you had with it up to now. Again, very interesting blog post, build smarter AI agents, managing short-term and long-term memory with Redis. That's by our colleagues, Manvinder and Andrew. It's very interesting. If you have the time and interest, you should definitely check it out. It explains how this works, how to use the Redis agent memory and server, and how it fits in the whole picture. Finally, this is my experience with AI right now. It's a very sharp sword, but you could hurt yourself with it. So make sure you're using it in the right way. And that's hard because we don't know how it should be used right now. We're all learning as we're developing the whole AI ecosystem. But nevertheless, it's a sharp sword. So it could do a lot of interesting stuff and a lot of powerful stuff if you wield it in a right way. These are my contacts in case you want to reach me, or after the talk. I'm a bit faster than I expected, and I'm open to questions if you'd like to ask me something. Thank you.
First of all, thanks for the talk. Just yesterday, I attended a security event, and I was wondering about how MCPs work, so that was really in time. I'm wondering, how does a distribution of such, let's say, plugin work?
Mm-hmm.
Do all LLM providers or whatever have something like App Store, plugin store for such things? And what's the security behind that? Are they verified in some way, signed in some way, the configurations and so on? Sure.
Yeah, so I'm going to repeat the question so that everybody hears it. The question is, how do we distribute these pieces of software, and how do we handle security in regards of credentials and secrets, I would assume. Now, the current way that we do, let me start from that, the place where we're basically seeing new ways of distribution as we speak right now. Just a couple of weeks ago, a new store kind of was opened, where a new format in which you can package your MCP server was advertised. Several have already died out, like Smittery, for instance, or at least changed their purpose. So it's a very changing topic. There's not really a single approved or way that everybody agrees on. But right now, in most cases, they're distributed like a, because most of the code is written based on the framework it's written in. For instance, the MCP server that we developed is written in Python. So there's several frameworks that are very popular for Node.js, for Python, Java not that much, and they are distributed in the same way that you distribute an application written in the ecosystem that you're writing in. So for Python, that's PyPy, for instance, or some other way that you would provide. Like you could basically, my demo was pulling the MCP server from a branch in GitHub. Not perfect, but it does what I wanted to do. And there's a way to package them depending on different providers that will help you. Help me here. What was the name of the latest one? The packaging, the packaging that you could do to get in the store of, was it Anthropic?
It's already listed on Gemini.
Gemini.
Of course, yeah. And also working to list it on, there is GitHub registry.
Yeah, there's GitHub registry, there's Gemini registry, so there's different ways. I don't think we sign it.
Not yet, yeah, but it's listed as a trusted, so basically the
Yeah,
itself.
we give it to them and they say that it's okay. So it's very secure. Credentials, obviously, this is one of the purposes we created this in the first place. You keep them, there's different ways to provide the credentials to your MCP server, and it's a bit up to you which one is most safe in your organization. It could be an environment variable, it could be part of a configuration script, it could be provided to the process as parameters, so different ways, but ideally, would the user know what he's doing, he is able to secure them in a way that they don't leak. Does this answer all questions? I'm going to come so that I can hear you.
Hi, thanks for the lesson. Look, for probably 1.5 years, I used Redis for early experiments with agents for conversation memory, short-term memory. And the main reason was high throughput and speed, right? Now you said you have your agent. It's the first time I hear about it. I will obviously try it out. You say you have your agent that can be connected for short-term and long-term memory, and you mentioned that there are both REST and MCP connection. I wanted to ask you about MCP. You have some doubt, like what about throughput and speed comparing REST and MCP? Because obviously MCP is more handy in terms of how to use it, right? More handy and easy to build more complex and deviation setups. But what about throughput and speed?
Okay, I'm going to repeat the question again. The major question is, are there concerns and how do we handle speed when we compare communication through REST and from the MCP protocol? Just to correct you, this is not an agent that I showed, it's an MCP server. Again, the agent, I don't think we have an agent in Redis.
No, I actually mean the server.
Yes.
Short-term memory.
Yes. So again, for short-term memory, the memory server has two options. Unfortunately, I can't talk a lot about it because I don't work on it, but I'm going to give you a brief an uneducated answer to your question, I would say, because I haven't actually tested out speed. I assume that usually when a person decides to use the MCP protocol, they are not really concerned with throughput and speed, because the MCP protocol is, I mean, you saw how fast it is when you use IntelliJ. It's not really fast. If you want to have speed and throughput, you would model your whole system in a way that would be more performant, probably with REST. But having asked this question, this would still be slow if you want to do it. If you want to take advantage of Redis with its high speed, probably another interface, like a REST interface, and some sort of binary serialization of data would be much faster. Again, it really depends on the use case that you want to serve, because most of the use cases here are conversational and thus inherently slow, and you don't really benefit a lot from the speed. You benefit more from stuff like, because you have two aspects here. You have the speed of communication with the server, which is one thing, and you have the speed of processing of the query that you gave the server, which is another thing. So eventually, if what you want to have is a fast way to understand, like search some data in Redis and use the capabilities of the Redis query engine, you would still get the performance of the Redis server, but you would have to, accept the slow MCP conversational part, because if this is your flow, you have nothing to do about it. It's just how it works.
That's fine. It's clear. Thanks for the speed part. And what about the throughput? It's kind of the same.
Yeah. Thanks.
What about the throughput part? I mean, because when we use Redis when we have multiple, very many conversations at a time, very many sessions. What about the throughput part? Are they the same or not?
I would say I would say that it's not really optimized for large documents and throughput. Again, because it's more of a supplemental part to the, you would basically have a lot of context to pass around. And you know that if it's used for RAG, one of the consequences of using RAG is that you're extending the context window of the prompt that you have. So you can't do that indefinitely because you get a huge hallucination based on your prompt. And that's the limitation of the technology right now. But again, I'm talking here very broadly. It really depends on the use case. You may do, as with other stuff, you may do one thing in several different ways. And depending on the way that you choose to do it, you may get more throughput as a result. But I would not use specifically the MCP servers for throughput or speed. That's, at least right now, what I see, that's not their power. Any more questions? I can open. Yes.
Yeah, you mentioned about the long-term and short-term memory, and I was wondering how do you decide what kind of information to save in the short-term memory and what kind of information to save in the long-term memory?
Again, it's more of a question to how to build an AI agent flow, let's say, agentic flow, based on the purpose of the system. I can give you a very general explanation of it, but based on the purpose of the system, usually you would use short-term memory for stuff that is part of the same conversation or the same prompt also, because this type of short-term memory, it does not participate in later interaction because, again, we'll build a too broader context window for the initial request to the LLM. It's more like, for instance, the steps that we described here for finishing some task. You have the session of the prompt as the time that this information is limited to. In our case, like if I ask the agent, can you prepare some demo data and put it in my Redis instance? It would go to the LLM. It would ask, what should I do in order to prepare demo information for this model? And it provides the model. And then the list of tasks that the LLM would return would be very good candidate to a short-term memory, because this list of tasks you don't need for the next prompt, obviously. You could extract some information, like if you ask the user, if the agent asks the user something like, do you use Redis as a database? Because it does not know initially. And you say, yeah, please use Redis, then this is a candidate for the long-term memory. Because again, when another prompt comes, today, tomorrow, or some other time, it could assume to use Redis based on your long-term memory. It's not perfect, obviously, because you may be using Redis just for today, but this is the state that I know of. One question here.
Yeah, if I understood correctly, currently you're running the MCP server locally on your machine, right? Are there any plans for it to be publicly available through the Redis cloud or some other way?
You're supposed to ask easy questions.
Sorry.
Yes, currently the state of affairs is that we are distributing, as I mentioned, the server with PyPy, and or you could use it from GitHub, whatever, and it only uses as standard I/O for communication. It's a limitation for now that we want to change. First, I think we're going to start with a streaming HTTP as a first step. You would still have to host it yourself, but it will be available through HTTP, which makes it easier for you to start a Kubernetes container somewhere and it being like a service in your environment, but still local. And eventually, but again, we're not making here commitments. This is not a commitment. Eventually, we would probably want to have a service, especially for the cloud, because Another thing you could use this MCP server for is you could have a connection to your cloud instances for Redis. And obviously, a cloud service that acts as an MCP server for cloud Redis instances makes a lot of sense. But for now, we don't have a clear roadmap for it. We want to have it. If somebody wants to contribute, because Redis is open source, don't listen to what people say, it is open source, so you're welcome. Any more questions? I can talk about how flooding your apartment slows you down to prepare your presentation. This is one of the things that happened. Well, if not, thank you very much.